Hello and welcome to this video on the embryology of the eye. To understand the eye development, it's better to have an overall picture of how the eye develops. So this video will give you the foundations of what you need to know for the FRCOphth Part 1 exam. To understand embryology of any structure in the body, you need to understand the germinal layers. Essentially, all we need to understand is that there are three main germinal layers. There's the ectoderm, the mesoderm, and the endoderm. So the ectoderm are split up into surface ectoderm, neuroectoderm, and neural crest cells. The vast majority of the structures in the eye are made up from ectoderm and split into these three categories. You also have mesoderm, which can be linked to mesenchyme, and you also have endoderm, which is not involved in eye development. Embryology can be hard to understand because it's hard to picture what's going on. We don't really have a tangible framework to work off. So let's try and work backwards so we know what we're aiming for. If we look here, this is a schematic, a basic schematic of the eye at day 33. So we know we need something protruding, specifically nerves, to form the optic nerve, okay? In embryology, it's called the optic stalk. Then we have the retina. It looks like it's two layers here, right, in different colors. We of course need a lens, and then we need a cornea in front of it. That's what we're aiming for by day 33. So our journey will start at the neural tube. Of course, there are development stages before this, but they're not really relevant for the FRCOphth Part 1 exam. So if we start the neural tube, at the most cephalic end, the head end, we have the telencephalon and the diencephalon. And together, they're called the proencephalon. So that's the proencephalon. Specifically in the diencephalon region, this is all the forebrain, we have these two buds coming out, okay? Now they're termed the optic sulcus. As you can imagine, we need something to form the optic nerve, so we need some protrusions going to something to then form the eye, okay? And this is what happens. The optic sulci protrude, they form an optic stalk, these continue to create an optic vesicle at the very edge, okay? Now let's look at that diagram in a bit more detail. So we've got our optic sulci. Let's look at that diagram in a bit more detail. We've got our optic sulcus on the edge here. In this invagination of the neural tube, we have neural folds, okay? And these are created by neuroectoderm, okay? This is all neuroectoderm. And on the outside, we also have ectoderm, but because it's on the outside, it's on the surface, this is surface ectoderm. Now let's look at this area here. We know the optic sulci protrude to form the optic stalk and the optic vesicle, and this happens at day 25, okay? This happens at day 25, the optic vesicle is formed. So we said we have the neuroectoderm here. This is the optic vesicle and also the optic stalk. And what was that overlying in the green? We have the surface ectoderm. The surface ectoderm is overlying. And you can see here we just have a thickening of the surface ectoderm, and this is termed the lens placode, okay? When this thickens and causes the lens placode, this causes the optic vesicle to invaginate, okay? So the lens placode thickens and it triggers the optic vesicle here to invaginate. So we have the surface ectoderm, we have what was previously the lens placode, which is now invaginated to form the lens vesicle. This happens at day 27. If the lens placode is invaginated to form the lens vesicle, this is going to force the neuroectoderm behind it also to invaginate, and it creates this like double layer here of neuroectoderm. As development continues, the lens vesicle continues to invaginate, and as we said before, the neuroectoderm also invaginates, creating this double layers. The posterior layer here, which is slightly more pigmented, forms the RPE, the retinal pigment epithelium, and the more anterior neuroectoderm forms the sensory layer, the neural retina. As you can imagine, if we continue with lens development, this area here of the lens vesicle pinches off and forms the lens. This is the embryonic nucleus, okay? Here we can see a bit more of a developed structure of the neural retina. We have the sensory retina here and the RP behind it. Then we also have this optic stalk structure, which becomes the optic nerve. So if we look anterior to the lens, we've got this layer of surface ectoderm again. So this layer comes as the lens vesicle pinches off, this surface ectoderm reforms and reforms this layer here. Okay, this layer develops into the upper lid, the lower lid, and then also the cornea, but specifically the corneal epithelium. Okay, so let's try and work back from the original structure we had here. Okay, so first we know we have the neural tube. So we know from the diencephalon we have these two protrusions here. The protrusions are the optic sulci. They extend to become the optic stalk and the optic vesicle. So that brings us to structure A. We have the optic vesicle and this is the optic stalk. Overlying that we know we have the surface ectoderm. The surface ectoderm then thickens to form the lens placode. When that happens, this then triggers the future neural retina to invaginate. The lens placode also invaginates to become first the lens pit, then the lens vesicle, and then eventually the lens in entirety. The same thing will happen to the neuroectoderm. The neuroectoderm will invaginate, and that will cause this double layer. So the most anterior layer is the neural retina, and the posterior layer is the RPE. Once the lens vesicle fully pinches off from the surface ectoderm, the surface ectoderm then reforms, forming the cornea, but specifically the corneal epithelium. So now we have our structure in D. We have the optic stalk or the optic nerve, that's our protrusion that comes from the diencephalon. This forms a bilayered structure of the retina, so the RPE and the neural retina. Anterior to that we have the lens, and then we have anterior to that the cornea. Interestingly, the very anterior part of this neuroectoderm, we have the future ciliary body and the iris. Okay, so this is all connected, and the ciliary body and the iris also come from neuroectoderm. So also running in this optic nerve or optic stalk is a blood supply. The blood supply supplies the lens. Okay, this is jumping forward a little bit. We'll go through this more in the lens video, but just understand now during the development, the lens needs a natural blood supply. Postpartum, it's nourished just by diffusion of electrolytes, but during development, it's supplied by the hyaloid artery. And if we take a cross section of the optic stalk, so we have this structure here. Just like the rest of the neuroectoderm, there's an outer layer and an inner layer, okay? And then running in the middle, we have these hyaloid vessels. They go on to supply the lens and the primary vitreous. To allow passage for the blood vessels to flow through to nourish the lens, it needs to flow through this little area here. This little area we call the choroid fissure. This fissure needs to close to form a fully formed optic nerve which is fully sealed off. And if this doesn't happen, the patient's at risk of lens pit, iris coloboma, etc. Right, let's go back to the beginning and let's go through these germinal layers. Can we fill in which structures come from which germinal layers? This is super important because it comes up in every exam and it's super easy marks. Okay, so the structures coming from the surface ectoderm are anything that's coming from this very front part of the eye and anything that buds off. So we know we have the corneal epithelium. We also have the lens. And remember, we also had the upper lid and the lower lid. So the skin of the... Perfect. And now the neuroectoderm is anything that comes from behind this. Okay, so what do we have? We have the retina split up into the RPE and the neural retina. Then we also have the optic stalk, which becomes the optic nerve. And then remember, at the anterior portion of the neuroectoderm, we have the future ciliary body and the iris. The neural crest cells develop later, and they go on to form mainly structures in the anterior chamber. We'll go into this in more detail in the video about the anterior chamber. Also be aware that parts of the iris are also formed by neural crest cells. As always, let's go through an exam question which came up in my paper. This is what they gave me, and this turned out to be a super easy question, okay? Some of the questions are this easy in the exam. They had this structure here and this label A. So what does the structure A develop into? Is it the choroid, the RPE, the lens, or the cornea? So what do we have? This is the optic stalk. This is the optic cup. So we have surface ectoderm here, which is invaginating and pinching off to form what? The lens vesicle. So therefore, it's going to develop into the lens. If that wasn't easy enough, they also give the hyaloid vasculature here, which we know supplies the lens. So therefore, the answer C, the lens. As always, if you want more resources, more questions, click the link in the description and that'll take you to my website. All the best.